Thank you, everybody, for coming to my talk today. Before I get started and dig into the material, I have one small request. I'm Scott McAllister. I'm a developer advocate from a company called ngrok, and I come from the city of Seattle, Washington. Thank you for having the temperature a lot warmer in this part of the world. There was ice on my car when I went to the airport yesterday. So thank you very much for having non-ice conditions here. But two, I need you all to prove to my bosses that there was a reason why they sent me to Columbus, Ohio to go speak in a movie theater. So if you all could smile and wave. Awesome. Sorry I don't get the people in the other theaters, but we'll figure that out. So if you're here today, you're here to talk a little bit about testing. My hope and my goal is to share some ideas, some tools you can use, some philosophies you can follow, but also kind of have some ideas to take back to your teams to say, okay, we want to do testing, we want to do end-to-end testing, and we want to do it with containers. Here's are some of the topics and tools I heard about at this conference. So that's the hope today, that you can learn a little bit about what I've found in my experience with the topic and with testing in general, but also testing in containers. To start and level set, we want to talk about the fact that testing, the whole point of testing, you want to evaluate and verify that your code is doing what you expect it to do. Whether you are releasing code internally or out to the world, there's two important things that we need to have with our software. One is that it works, because if it doesn't work, no one's going to use it. And two, that we can push out changes quickly. And testing does that for us, especially when we make it automated, when we put it in part of some kind of automated pipeline that makes it so that it happens without human interaction. So we're going to talk about different types of testing today and talk about different strategies that you can take. When I was talking to an engineering friend a couple of years ago about testing, and I was saying, hey, man, what's the biggest tip that you have for writing good tests and testing software? And he thought about it for a second and started chuckling. He's like, you can't test code that isn't written to be tested. You need to be able to write testable code. And testable code, as he described it, is code that has a single responsibility, something that has individual, distinct spots, distinct things that you can test, that you can try out, so that you can see that it runs independently of everything else. It's decoupled from everything else. So something to keep in mind, because testing, as Adler says, makes us better developers. It helps us create better documentation. It helps us be more productive, but also helps us build better software. A few different types of testing. First, we're going to start small. Small with the unit testing. Unit testing is when we test the smallest little modules, the smallest piece of functionality inside your application that can be reasonably isolated. When you do that, you're going to be doing that often because these are quick little tests, making sure that the little pieces of the application are working, and that way you can move out to bigger parts of your application. So we have a design of an application here. I thought, since we're in a movie theater today, we'll think about, let's write a software that a movie theater would use. And so in this case, we have probably a web UI, probably a mobile UI. We have a chance for a place for users to manage their stuff. So you have user services. They're probably going to buy concessions. You have concession services. But then the movie ticketing section, that possibly could be an external service. So you're going to be making calls to an external API. So you can process your movie tickets and process how you would handle that inside your theater. But your services are going to be going into a data store that you have, that you could control. So if you're going to unit test this application, you would want to be thinking about how you would take little pieces of functionality inside of a singular service. So in our situation, we would think, okay, so inside the user service or the user API, not only do I want to test the whole service, but I want to test each individual action inside of there. So I can say, okay, let's test out, does the create user work, update user, and then all the different fields that we would use. What happens when there's an error? What happens when they put in maybe some nefarious code inside of the form, or that gets sent into that API, that type of thing. So the unit testing you want to do in a much smaller, much more isolated area. Expanding out from unit testing, we will go to integration testing, where we start combining our different modules. We want to start thinking about how does my service interact maybe with my data source and work with realistic looking data or saving data into the database. So we can say, all right, I'm going to take my user object, my user service, and say, here I want to write a test that generates a thing and saves it to the database, maybe pulls the thing from the database, or maybe how it interacts with the other services and how the user API would interact with the concessions API. So we're stepping out a little bit further in scope, but still just testing parts and pieces of your application. That leads us to end-to-end testing, and that's where we want to test the entire flow. And by testing that entire flow, rather than initiating tests from the API level, we're going to be initiating tests from the front end because that's where our users are, at least in the case of this application, right? With the web application, you have users that are going to be coming in through a user interface. And so with that end-to-end testing, we're going to have tests that essentially manipulate the UI to be able to perform actions with that, and then perform actions with the services and the APIs, and then see how that interacts with the database. So it tests the entire flow of your application. In these cases, you can see all the red there, all the pink. It's a lot of resources. End-to-end testing, it's heavy on your processes, but it's extremely valid. And all the testing needs to come together. All of them have their place. You have unit testing that tests the things that gives you the confidence to push code live. Then integration testing gives you a little bit more confidence that things actually work together rather than just each individual piece. And then the end-to-end testing is what makes sure, okay, the whole user experience on these particular flows are actually things that we expect to happen. And there's a couple of reminders in life, right? When unit tests totally passed, but then we have integration tests that, they just didn't think through how each individual object works together. This is another good one. We have a lock on a door. The lock is installed correctly. Nice little hole in the wall. Perfect. Okay? Seems like it should work. Sort of. How many of us have written software like this? Right? Yeah, me too. Totally. You wrote a thing, thought it was great, then you ran it, went, oh, wait, it's supposed to go the other direction. It's supposed to go the other way. Something to keep in mind. So thinking about testing, you want to have these tests, especially end-to-end tests. You want to have testing environments, making it so that it's a lot like production. And I know that in the years that I've been in software development, keeping test and production the same has always been kind of a trick, even a bit of a chore. And so in our case, this particular user has a test environment that looks kind of nice, smooth sailing, maybe a little bit of a ramp, a little bit of obstacle on it. But production actually looks something more like this, where you're going to have lots of different risks involved, or things where your application is going to lag possibly, or performance will fall over. So something to keep in mind, we want to keep our test environments as close to our production environments, and that's where containers come in. So let's talk about containers a little bit. I want to talk about the definitions of various terms inside of containers and Kubernetes and things. That way we're kind of all on the same page. So containers, also, I wanted to relate to today, actually. So this test environment, right? We have a pod racer that has 2 engines, okay? Looks nice. It does what it's supposed to do, right? It races down a course, goes fast, but in actuality, production is a pod racer with 4 engines now, and those engines are connected differently, and they're probably using different versions of different components, and the situation is not the same. They look the same, maybe, or really, really, really similar, but that is not a 2-engine plane, or pod racer. Now we'll talk about containers. So with our applications that we have code, and then we have the dependencies that run that code. So if you have a Node application, you need the Node runtime. If you have C#, you're going to need the .NET runtime to be able to run that code, and various dependencies that you might need to run that application. And so you might have an environment where you have a server, and you have those things installed. You have an operating system. You might have databases and things all in the test environment, then also in the production environment. But with containers, you can take all those dependencies and package them up into one little package. We'll call it that. So inside that container, we can have our code that I can write. I can have all the dependencies encapsulated with my code. And then I can essentially, in theory, I could pass it over to you, and you could run it on your machine. We could pass it over to our data center, and that same container can run over there. We can have it running in production and running in test. And they would have the same dependencies, same configurations. Just when we update the code, we say, OK, we're going to push new code and make a new image or make a new container or new image with this container. So with those containers, the most popular runtime for containers still, probably, at least definitely the most visible, is a company called Docker. Docker has released these types of statistics, basically saying that running and developing with containers makes us a little bit more productive as developers. Something to keep in mind, things are faster, either in production or in remediating issues, but 13,000% productivity increase. That's a lot. 1,300, sorry, 1,300. I got these stats from Melissa Benua. She has a great talk on continuous testing with containers. She got them from Docker. I couldn't find them from Docker. So I'm going to reference her because she's a solid resource and a solid source to give. But that is where these numbers come from. So we have our container, and most of our applications are not going to be one single container. We're going to have multiple things. If we think back to our movie theater app, you're probably going to have a container for your user service and a container for your concession service. So when you start thinking about all of this and thinking about how your application is going to expand, adding more functionality, you're thinking about a lot of containers. That gets a little hectic because you have all these different isolated objects, isolated instances of things running in isolated from one another. So you need to be able to have a way for them to talk and for them to get together and to kind of orchestrate or essentially find the calm amongst the chaos. And so that's what Kubernetes tries to do. Kubernetes is a way for running multiple containers in an application or in clusters, and then you run that application, you configure it, and Kubernetes handles all those different configurations you would need to make sure that the containers can talk to each other, that they operate properly, that they can have access to the outside world, those types of things. With Kubernetes, you have containers are inside of a pod. So inside that pod, the pod is the atomic unit inside of Kubernetes. And so a pod has a single container. It can have multiple, yes. But in our case today that we're going to be talking about, it has a single container so that you can separate out separate out the functionality so that each container or each pod can have its own responsibility. Inside our pod, as we mentioned, we could have multiple pods inside of our application because we're probably going to have multiple pods. So we need to have those pods to be able to talk to one another. In this case, then we would deal with we would configure an object inside of Kubernetes called a service. A service is a way for having all the different pods talk to one another so they can have communication among their own little private network inside of your cluster. This is called east-west traffic, but it's closed to the outside world. When you want the outside world to talk to your pod or talk to your cluster, you would configure an object called an ingress object. That ingress object is what connects users to your application inside of Kubernetes. And that way you can have east-west traffic of things talking to each other, making sure that all the different pieces of your application are working in harmony with one another. But then also you have users that can actually get into your application and use the thing. So in production, usually, and again, this is from the research I've done, the people I've talked to, and the observations I've had, usually you're going to have your cluster, it's going to have some various pods, and it's probably going to be talking to a data store outside of the cluster. You can run databases and data stores inside of a Kubernetes cluster. People do. However, most people, when I've talked to them, they are using a database that's sitting outside the cluster. It's sitting in an external service, most likely, but usually a database that's kind of running on its own thing. So in that case, there might be a little bit of difference when you're doing things in testing. In this case, we could have a test environment where we have the front end and the back end pods, but then you're probably going to have the test code running in its own pod inside the cluster, and then probably going to temporarily spin up a test database. where you do that and you can keep that all encapsulated. That way you can spin up the database, maybe populate it with some data, test stuff, and then spin down the database when the tests are all done. The point here is to show that the similarities, you try to keep the similarities as close as possible, even though they won't be exactly the same. You can try to keep things pretty close to what they are. So getting into our demo today, what I want to show you is an application that I built running that has a couple of different containers, a couple of different pods running in a Kubernetes cluster, and it's a subject that's near and dear to my heart. I love hamburgers. Who loves hamburgers? And I do too. So hamburgers are awesome, and so I love to keep track of places where I have good hamburgers. If you can tell me later some good places to get burgers in the Columbus, Easton area, I'm all ears. This is keeping track of the burger places that I have in Seattle. What I want to show you is this bottom half of the slide. Because we don't have the internet in here, at least I was told we don't have internet, and I'm operating as if I don't have the internet. This is my web application. I want you to see it so you can visualize it. We're going to be talking about testing this code later. We're going to be talking about testing this UI. And so when I say find the add button and then click the add button and then type into a form so it adds it to a list, you can see, OK, that's the Burger Places app that we're talking about. The add button is sitting there. OK, we see that. And then when we add a thing, it's going to get added to that list below. All right, so you can have a mental model of what I'm talking about. That way, when I'm talking about the tests and showing code, you can think, OK, I can at least see what the page should look like. The architecture of the application looks something like this. Production is just a simple front-end container, and then a simple back-end container running it with some C# code that's providing the back end. I do not have a database in this application. I'm storing all that information inside of memory, inside the container, just because it's a sample. But my test is almost identical to production. The only difference is I have test code, but that test code container I didn't put into my cluster. That's because you'll see in a little bit when I show you the pipeline that I built, you'll see where I put the test code, but the test code is running in its own container that's going to be initiated inside of our GitHub action that we're going to be talking about. Which leads me to talk about the different tools that we have inside of the demo that I want to be discussing. The first is Cypress. Cypress is a tool that allows you to write code that manipulates a website, essentially inside a web browser or inside of Electron, I believe, are the two areas. I think there's other areas too, but those are the ones I know of right now. You can even pick the type of browser you want, the version of the browsers you want. In our case today, it's going to be running in a bash script, so command line, so it'll actually be headless. You're not actually going to see any of the browser stuff happening, but we'll see outputs of the different test results. And then finally, GitHub Actions. GitHub Actions are going to provide a way for us to automate a flow where we're going to push some code to a repository, and then we're going to fire off a bunch of instructions to make that work. And then we're going to have our application essentially deploy, or at least test. It's going to deploy at some point, but today we're just going to test our application to make sure that the code is doing what we want it to do. So now I'm going to jump out of slides, and I'm going to jump into that code. I will say, I'll give you a heads up, I'm going to be jumping around from files. What I want you to do is just try to keep a mental model of what I'm talking about. That way, when you go back to your teams or go back to wherever you're going, or even if you want to watch the video later, you can say, OK, I know he talked about processing Docker files. He created images with that or containers with that. And then he did some tests. I know he did that. And then I know that, OK, here's some Kubernetes manifests and how he managed or configured his Kubernetes with that. So I'm going to pop between those different files to kind of show what our application's doing. The first is we have our backend. I'm not going to talk about each line inside of our backend or our front end. The important stuff is to see that at the top there, we're grabbing a dependency. We need to get some .NET, the .NET framework in there to run our C# code. And then we're going to have a list of commands that actually are required to get that code running and compiled and make it a runnable application. Then we have a front-end container. Again, the front-end container needs Node. And so then it's going to pull over some of the front-end code. It's going to copy it into our container. and then make it possible so that when it's all there and ready to roll, it runs an npm start so that we have an application that we can use and that Cypress can hit and that users can hit. Okay, and now our Kubernetes. So we have our two different our two different pods, our two different containers. And then very quickly, inside of our Kubernetes configuration, we have a deployment here. A deployment is a way that we build that pod, the pod that we're talking about. So we're going to take the container for our backend that we have down here. So we have our backend specified inside of our container section of our configuration. And we're going to, when we take that, when we build that image with Docker, it's going to be named burger back. And then it's going to have these capitalized variables in it. I'm going to show you, these are actually something that we use inside of our GitHub action that I'll show you here in just a second what we're doing there. But the important part is that we're grabbing our containers, and then we have our front-end container here, taking the same type of configuration. And then we have our services so that our containers can talk to one another, or different pods. And then finally, we have our ingress. Our ingress makes it possible so that users could use our application, but also that so that Cypress can get to our application. Ingress is, like I said at the beginning, it's that north-south traffic. It makes it possible for the outside world to get into our cluster. In this case, we're using ngrok. Ngrok is an ingress platform that allows you to get access into things, and so, or at least provide that access in a secure and easy way. If you really want to set up ingress in a regular Kubernetes cluster, you're going to be setting up lots of different pieces. You're going to be setting up DNS, you're going to be setting up load balancing, you're going to be setting up certificate management. And with ngrok, you can have all of those collapsed into one thing and one place, and it can manage that for you. And so in this case, we have ingress that we're going to say, you can access this application at a URL that we're going to specify at front-end URL. This is a good time to pop out of this code and actually show you some settings that we have in GitHub. Because I'm going to come over here to our GitHub GitHub action. But before I get into that GitHub action, I want to show you some parts of the GitHub UI. Let's see, that's the one we want. And inside here, I recorded going through some of the different pieces of my GitHub account or my GitHub repository. That way, you could see it inside of your UI. So you can say, oh, right, I was supposed to set variables or set secrets. And so if you want to set variables and secrets inside your repository to use inside your GitHub action, you would come over here to your settings. I about clicked on it because I'm not used to running videos. But anyway, so you run this here. It's going to click on the settings. And then in here, you go down to that security area. You go to your secrets and variables. You want to set them for your actions. And then here, inside your secrets area, your repository secrets, when you set these, you don't get to see them again. So similar to if you're going to setting an API key somewhere or on a particular API, usually they'll give you your API key once and then be like, hey, you're never going to see it again, so you can't see it. In this case, you set these different variables. These are things that are sensitive information that you don't want to share with the world or have someone stumble upon. And so that's what you have here. So you'll see some secrets inside of our GitHub action. And then also some variables. And that's what we have over here. We have that GitHub, that front-end variable. So our burger places test, ngrok.app. That's going to be where Cypress should be able to hit our application. And that's what's going to be passed in to our YAML back here, those all caps values that we were talking about throughout this file. So these types of variables here inside of our YAML. Over here, we have our GitHub action definition. Okay, and this is going to set up a GitHub runner that will come through here. I'm going to talk about some highlights. It's going to be running on Ubuntu, so it'll be a little Linux environment that's running inside of our action. And then that action is going to use some dependency. You use the uses variable or the uses attribute to talk about the dependencies that are coming into your action. So in this case, I want to do a checkout, which means I want to check out the code that's coming in through that commit. And so that's good. We want to use that because we want to check out the code that we're passing in. And then also, you want to use actions-k3s. This is allowing us to spin up a Kubernetes cluster inside of our GitHub action environment that's running. So it's meaning this temporary environment that's running on GitHub that sets up a Kubernetes cluster and runs our application. And then we get into a bash script that's essentially giving us the commands you would normally give inside of a regular bash script. If we wanted to write all the instructions out for creating our Docker images and then running those Docker images and then creating our GitHub or our Kubernetes cluster and using that, that's what these instructions are. We're getting into where our backend is. We're going to do a Docker build, which takes all of the definitions inside of that Docker file and builds that image for you. And so you have that image that has .NET running in it and all of our backend code. And then here in the front end, it does a Docker build, grabbing all the node and all those things it needs there to run our application front end. And then this line right here, I'm going to get that. OK, line 45. OK, I'll highlight that right there. This line I have to attribute to my friend Rob Richardson. Anybody know Rob Richardson? Really smart technical speaker, programmer, developer. He was helping me with this. He was smart with this setting up GitHub Actions. What this does, sed is a way that we can run a regular expression on a certain file and then do a find and replace. And in this case, I'm running this find and replace on my cates.yaml file. So that case.yaml file, remember, it had these all caps variables inside of it. And so I have 3 different instances where it's going to look for this docker_URL. And it'll take docker_URL and then replace it with the value that we have in the curly brackets over here. $, double handlebar curly brackets is signifying to GitHub, this is a variable that's coming from inside of the repository somewhere. So in this case, this is one that's going to be inside of the secrets. So secrets.dockerURL, that was one of the secrets that we had in the UI. And then we have image label, and it's just going to get the SHA for the GitHub commit. So the Git commit that's coming in, that's identifying our commit, that's going to be our label. That's going to be essentially our version number of the containers of the images that we're building. And then the front-end URL is going to be that URL that we put inside of the variable section. Before, it was burgers test or burgers places test.ngrok.app. And then it's going to take that from vars.frontend URL. So cool way to take variables from inside your GitHub repository and then put them in to your GitHub Actions. That way you can use them. But then also a cool way to manipulate a file using the sed command inside your terminal. All right. So then we're going to step down through those different commands. Inside of Kubernetes, we would need to install ngrok, right? So to install ngrok, it's a Helm chart. Helm is a package manager for Kubernetes. So we make it possible for different functionality to add it to your cluster. So in this case, we're adding ngrok to that cluster. And then we're going to do a kubectl apply. And that kubectl apply runs that manifest, runs those configurations to create our cluster and to see or to make sure that everything's running. In this case, I'm going to step over that. I'll explain that section later in just a moment. And then after we do a kubectl apply and we have our cluster running, we want to set up our test code. Our test code is running. It's in the same repository, OK? So it's in the same repository as the rest of our application. But we want to make it separated, the image itself or the container itself. We want to have that separated from our application. Because Cypress is kind of big, and it's going to bring in some other resources. And so I'll come out here and show that to our Cypress here. So I have my backend folder, I have my E2E, and I have my front end. My E2E right here, this is where my Cypress container is, or my definition for my Cypress container. So my Docker file is talking about how it's going to be pulling in some resources to make sure that Cypress is going to run. And then it's going to makes sure that all the dependencies that are defined inside of my package.json are there, and then installs them, and then runs that Cypress open command or Cypress run command there at the bottom to actually run our tests. And our tests are defined here inside of the Cypress E2E folder. We have these tests. I like how they write out their tests that make it easy to read. The points that I want to show that you want to remember as we look further inside of our discussion and our demonstration today is each of those tests has a name. And so those names you'll see in the output saying, did this pass? Did it not? And in our case, we have a test that's essentially it's going to our URL that we specify, and then it's going to say that first line on line 8 says, does the page even load? If it loads, sweet, that passes. Second one finds the button, that add button. Third one clicks on that add button. And then the fourth one, the resulting pop-up, it will put in a value. And then finally, after it puts in that value of the burger place, it actually checks the list to say, did that value get saved, and is it being presented to the UI? All right. So that is our test code. And we talked through here we have our test image. So we did a Docker build on that directory, and then we're passing in that front-end URL. And then when we run, we do a Docker run, which means once we have that image, then we want to run it to actually run the tests. We're going to say this is the URL we want to use, and this is the image I want to run. So in this case, it's burger E2E. And then eventually, we're going to want to, if everything passes and is fun, we're going to want to take these images, take these Docker images, push them up to a repository, and then change the context to production on our Kubernetes settings, and then apply those settings to production. Because we think everything passed with our tests, and then we can push things into production. So because we don't have the internet, like I said, we're going to go back to the recording that I did. Come back to here. I have it set up, as we saw on the GitHub action, I have it set up so whenever you push to main, it triggers this whole process. So I'm going to have this code here. I'm going to commit my code. There's a small change to essentially trigger the demo. We push it to our repository, and then we'll head over to the GitHub page that's running our GitHub Actions. So you go over to GitHub Actions, you see the one that's running, you click on the build, and it gives you an output of your logs as it's firing off. I'm going to just pause and then scrub through this a little bit. You can see here it's installing Kubernetes, or installing K3s, so that we can use with our application. And then go back here, actually, to this section here. These are the part in turquoise. Hope that's readable. The part in turquoise is those instructions that we had that was our GitHub action before that said each of the different bash commands. These are those, but they're now compiled with the values that we're passing in. The variables that we set with the all caps, things like that, those values are being set here so we can see, okay, I can step through that and say, okay, those all look good. That looks right. And then we'll go here. Then we get a lot of output like we do when we run like an npm install type stuff. I'm going to take this. We see some Docker output here. So we have a C#, our C# stuff that's happening here. It's copying our code. And rather than sit here and just look at all that stuff fly by, let's scrub this and actually come over here to the spot that's super interesting with Kubernetes. You can actually run, come on, there we go. We actually run Kubernetes inside of GitHub Actions, inside of this GitHub Actions. It's called a runner when it's actually doing a thing. And so by doing that, This here is let's go right there. You know, it's funny, I did this like dozens of times with my fingers before, but now that I'm doing this in front of people, I can't get the exact spot that I want to show. But we have our ingress controller that was installed with our Helm chart. This output right here is basically letting us know, okay, this is happy. It's happy that our ingress controller is installed. And then right here, down on line 298, is when we run our kubectl apply. That kubectl apply is telling us we have deployments, we have our services, we have our ingress, all the things that we had defined inside of our Kubernetes manifest are now being created inside of our environment, inside of this GitHub action. Okay. Then all this, again, is flying by. Let's go here. Yep, that's going to pause on that npm install for a minute. But I want to come here to the Cypress. This is the section where now we start seeing our Cypress test results. And we want to see, okay, so our Cypress image is created, and it's running tests against our code. And then here, whoops, went too fast. Right here, we have those different tests. We have those 5 different tests that we wrote out. Each one, they passed. It's good. So we're happy. We have our application, we have our tests, and it's running. But I have a confession. As an engineer, we're all engineers, yeah? And sometimes you have a deadline, and sometimes you still can't fix a bug by that deadline. What I just showed you was actually the tests running against my production application, because I still have a bug in my GitHub action. And so that bug in my GitHub action, literally right before I walked into this room, I started getting down a path where I'm pretty sure I can fix it, so that when I give a link after this talk to that repository, that code will work. Today it does not. At least at this very second, it does not, but it will. So what I showed you was how to run the tests against production, which end-to-end testing still needs to happen against production. It happens when we make commits, it happens when we make changes, but it also happens on a periodic basis so that you can make sure that your application is healthy. Canary tests is what the engineers at ngrok were telling me is what they call it. They run canary tests to make sure, is this process working? Is this flow working? So it's something you definitely want to have in your arsenal of basically taking your end-to-end testing and then running it periodically to make sure that your application in production works. All right. So now that I've showed you a sterilized, smaller situation or smaller example of what a test would look like, or what testing would look like, end-to-end testing, where we're testing an application from the UI and testing all the different features inside of that application, I wanted to take a step away from the small and talk about how we do things. Because for me, I like learning about how something works, and then, okay, now I know how it kind of works. How does the people really do it in real life? Like, what are they doing like in their environments? And so I talked to the engineers at ngrok and talked to them how they did their end-to-end testing. So I want to talk about how we do it a little bit to kind of see, if it resonates with any of you. So to just level set on what we are. ngrok is an application. We do have a web UI, but it's not the main part of the application. The main part of the service is a way to provide ingress or access into a particular environment. Started out as a tool that you could provide easy access to something running on localhost. Runs in your terminal, you would just put in that command, say the protocol, you give it the port, set a domain, and then that domain would get tunneled into that port on your system. It's progressed into a platform that not only provides access to local hosts, but also allows you to provide access to other networks, or like securely provide access to other networks. Say like customer data. If you have a service that you need to securely get to customer data, you can have something like ngrok to be that service. But by having that service in the middle, that's taking that traffic and routing it to where it needs to go, it offers you chances to be to use modules like authentication, IP restriction, load balancing, those types of things. Essentially, all I'm trying to say is web UI is not so much our main focus. It's more of something that's run either in a command line, bash scripts, we have SDKs, and you saw today in our demo, Kubernetes ingress controllers. Something that happens through those ways. So our testing has done in a few different ways. First, we have the manual testing. Manual testing is something that the engineers do. It's like a lot of the unit testing type stuff. And it's done on a scaled down version of K3s, same exact Kubernetes distribution that we were just using in our GitHub action. And it's a way for essentially for engineers to run repeatedly, to run often, but to make sure that their code's doing what they want it to do before they actually push it up into a repository so that other people can see it. It's either running locally on their machine, or actually, a lot of our engineers are actually developing straight off of AWS. Then we have some homegrown end-to-end services. So we have a couple of different services. One is it tests our APIs. Our APIs are kind of a focus inside of our type of product. But then we also have a thing called tunnels. Every time you create a connection between two different things, we call it a tunnel. It's tunneling between you and it. And so we want to make sure that our API, which allows you to do different actions with our service, are working, but also that the functionality, the core functionality of what our product does, actually is working. And so we have two different services there. We have that E2E global, which is the service that tests the APIs, and then E2E, which is running the tests against the tunnels. It's running on production every 60 seconds. Also, whenever the engineers are also running things. So it's definitely running a lot. It brings up the point that another key tool that we use that is used throughout a lot of end-to-end testing is something called test containers. Test containers is a library that allows you to programmatically, dynamically set up containers that can run inside of like a temporary scenario or a temporary testing scenario. So in this case, we use test containers to spin up a Postgres database. And so we spin up the database, we populate the database, and then when we're done, we tear down the database and just tear down it using test containers. We use the test containers Go SDK. I know that test containers, I think, primarily is Java. But they have lots of different other options in other languages, but we use the Go version. Some interesting numbers. We have over 500 tests with those services that I was talking about. And just in the last week, I was talking to my engineering friend this week. He said, just in the last week, we've ran it 47 million times. It's a lot. I was trying to do the math on the every 60-second thing, and I was like, there's got to be more. 47 million means they're running it a lot more than just every 60 seconds, because there's a lot of more minutes than that. And then 2.7 million times for testing out our API. So 47 million times making sure that a core functionality of our product works, and then 2 million times to make sure that our API works. Now, I did mention that we don't really have a UI. We do have a portion of our service that's a UI. There's a web dashboard, right? And that web dashboard is a web interface. You can visualize lots of things. You can do things with your account and with your different objects that you have, your tunnels, your edges. You can set up object or modules and things. So we do have some tests there. And we use something called Datadog synthetics. Synthetics is not their proper noun. Like, it's not a Datadog term. Synthetics is actually a term used in testing that some folks use interchangeably with end-to-end testing. I haven't gotten a solid answer, honestly, when I talk to folks. Synthetic testing sounds like it's more that canary-type testing, stuff that's running on an interval. And end-to-end testing seems to be running end-to-end tests on an interval. And so when it does that, it does synthetic testing, I think. That's what the different research I've done does that. But Datadog actually calls it synthetics. And so we use that to test out just simple actions inside of our web UI. That way we can make sure that that works. We want to make sure that our different functionality inside of our web application are functioning, and that's running every 60 seconds. as I mentioned, I'm Scott McAllister. I hope you learned something today. Who learned something today? Few people? Awesome. The way I learn and the way we all learn is you take the new things you learn and share it with somebody else. So be sure to share it with somebody else today. I would love to continue the conversation either on one of these social platforms or you can chat with me afterwards. Otherwise, thanks for coming today and enjoy the rest of the show.